All right, Mr. Stark back again. Here we go. We're going to do 8th grade math. We are going to estimate large quantities and small quantities to single digit times 10 to an exponent, to a power of 10. All right, so first we're going to start with the large quantity because this is a very large quantity and this is your little small quantity, which is between 0 and 1. All right, so we're going to start with the large quantity and we're going to estimate it to the first digit. All right, so 3. We have to look at the next digit to the right of it, the 4. Do we round up or do we keep it the same? If it's 5 and higher, you round up. 4 and lower, you keep it the same. 4 is 4 and lower, therefore we keep it the same of 3. Then we're going to fill the rest in with zeros. All right, it's just estimating it to this digit right here. So it's going to be 0, 0, 0, 0, 0, 0, and 0, 0, 0. Okay, so there we go. There is our large quantity. Okay, now we need to get it to be a single digit. So right now the decimal point's here. We need to get it to be a single digit of 3. So we're going to move it 3 places, 6 places, 9 places. Otherwise you can go by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9 to move the decimal here, which is 3. But there was 9 places. So 3 times 10 to the 9th. The 9 places is the exponent that you're going to raise the 10 to. So your single digit, this is for estimates, this is like an introduction to the scientific notation. So this is just using the estimates. 3 times 10 to the 9th, because we moved it 9 places. And a positive exponent is going to get you a huge, gigantic quantity. All right? So if you're moving it back to the 9th power, you go 9 places to the right, and that's where you get the large quantity. All right? But in simple terms, you know, a positive exponent, large number, you know, and the negative exponent is a really small number for most cases. So this is your estimate of this gigantic quantity here. All right, now hopping to the smaller quantity. And yes, I did do it literally, so I literally hopped to the next question. Okay? So now we want to estimate the first digit. We're going to round that Phoenix down, but don't worry, it'll rise back up again. There we go. Phoenix back in action. Always rising from the ashes. All right, so we're going to round the 5. We look at the 7 to see if we keep it the same or we round it up. 5 and higher, we round up. So that makes this 0.000006. It rounds up. The 7 tells you to round up. So we have 0.000006. All right, now we are going to change it to a single digit times 10 to a certain exponent. All right, we have to see how many places we move it to get it to the 6. 1, 2, 3, 4, 5, 6. So it would be 6 times 10, and since we moved it 6 places, the exponent's going to be 6. But if it was a positive 6, that would get this to be a gigantic quantity. Since it's a really small quantity, it's going to be a negative exponent. Because if we moved it back, the negative tells you to move it to the left. And if you move it back to the left 6 places, you would get 0.000006. All right? So the really tiny number is usually the negative exponent. All right? So this would be a rough estimate of that small quantity there. All right, that's what you need to know for now, and we're going to get into scientific notation later on, but this is the estimates, and hopefully it helped you with the large quantities and the small quantities.